can see by the multiple choice options that this is a hypothesis test for two proportions. We've got two samples. Um, there's proportions that we're trying to see if there's any significant difference. And if we look at the second to last sentence here, a significant test the claim that this has an effect on rhinovirus. It says has an effect, so it's not telling us whether it's making the proportion be greater or less than. So that's pointing us to an alternative hypothesis where it says does not equal to. I mean, we'd really be expecting, I don't know what Ekanaki is or whatever that is. But we really, I'm assuming they're doing it because they're thinking it's going to reduce the proportion. But if we just go off what's given us in this problem, it doesn't say less than or greater than. So the alternative could be this one. We're not going to go with that one because that's less than or equal to. The null hypothesis is supposed to be the opposite, right? So if your alternative does not equal, then your null hypothesis should be equals. So that's our correct answer here. Test statistic, we're going to go over to statdisc.com, analysis, where it's a hypothesis test that we're doing, and it's two samples. It's P, it's a proportion with two samples. And so you just type your information here. So in the first group, placebo group, there's 89, the first group that they list is, there's 45 people, 45 subjects, 42. And the number of successes is 35. And it's kind of a weird thing to say, success being rhinovirus infections, but it doesn't necessarily have to be like something good. It's like the significant thing that you're testing for is the number of success. As long as you keep this consistent and this consistent, as long as they're counting the same thing, you're okay. Placebo group, 89 of 100, so it was 103 subjects. 89 developed the infection that we're studying. If you click evaluate, it'll give you everything you need. The test statistic looks to be negative 0.48. P-value, actually I didn't here. This is it. This is the right alternative hypothesis. Just watch out for that though, because I skimmed over that part. If our alternative hypothesis was that one proportion was greater than the other proportion, we need to choose this option. That would change the p-value, but our p-value is 0.633 when we round to 3 decimal places. And then our conclusion is the p-value is greater than 0.01, right? So that means we reject the null hypothesis. If the p-value is low, reject HO. If the p-value is high, then you can't reject HO. There's no significant evidence. If you have a high p-value, your test can't tell you much. There's no statistically significant evidence. Oops. P-value is greater than alpha. Oh, I said that wrong. Fail to reject. There is no significant evidence. Sorry, that's a straightforward mistake on my part. If the p-value is high, you can't reject the null hypothesis. So I should have chose fail to reject. That part I said was correct, but choosing reject obviously is wrong if we fail to reject the null hypothesis. Confidence interval, that's also spit out here. 3 decimal places. So third decimal place gets rounded up. This one gets rounded up, so this is 100. Let's see. 3 decimal places, -0. Oh, it's a 99% confidence interval though. So we need to change significance to 0.01. And there's our 99% confidence interval. Conclusion. So the confidence interval contains 0, right? So because the confidence interval limits include 0, that means there does not appear to be a significant difference between the two populations, because that means that they could be equal to each other. One minus the other makes nothing, it makes 0, so they could be equal to. There is not evidence to support the claim that there's some sort of difference in those two proportions. Does it appear to have any effect? We're saying, with the p-value, and if it's a two-sided hypothesis, the p-value and the confidence interval will always agree. The p-value and the confidence interval, they're both saying no effect, no statistically significant evidence. So it does not appear to have a significant effect on the infection rate.